Hello everyone, welcome back to the SWAM NPTEL course on engineering aspects of biofuels and biomass conversion technologies. I am Professor Ijaz Ahmed, currently assistant professor in the Department of Chemical Engineering at IIT ISM Dhanbad. In module 9 of the course, we are discussing about the biogas production from the biomass. And earlier we have already seen or we have already discussed overview about the biogas production process. And then we discussed that what happens during the digestion. In short, I can say that we also discussed the anaerobic digestion process, where we discussed about the four-step conversion process of biomass into the biogas using the hydrolysis step, acetogenesis, and methanogenesis process. To continue with that, herein we'll discuss about the different components of the anaerobic digester and the factors that affects its design parameters and what are the factors that we should consider while designing a anaerobic digestion plant for the biogas production. Particularly the important components and the important terminologies as well as the factor which affects the most on the performance and yield of the biogas, those will be discussed here. There may be some smaller parameters as well and the process design aspect. If you remember in the previous class, we were discussing about the biogas production multi-step process, hydrolysis, acidogenesis and methanogenesis as well as acetogenesis. And eventually we concluded that the biogas yield and the methane content in it doesn't depend just on these microbes, but as a whole soul, it depends on the lot of parameters. For example, feedstock composition, biodegradability of the feedstock, microbial population, growth conditions, temperature, or any toxins that can contaminate or may inhibit the process. Okay. Now, let's discuss about what are the different components in an anaerobic digestive system. Okay. So, as we know that there are several processes that can be used alone or combination to treat and manage the manure. Okay. So this figure demonstrates like this is an anaerobic digester. This converts the organic waste into biogas and useful product. Then what we get? We get digestate. So that means we have a digestate here. That means we need a digestate handling and utilization system. The other product is biogas. That means we need a biogas handling and utilization system. Now the digestate handling and utilization system shall have liquid and solid separation in downstream. Then the solid fraction that we get are the fiber products, compost, fertilizer, soil conditioner, bedding, etc. Whereas the liquid fraction has liquid fertilizer, flush water, and nutrient concentrates. Okay. While in biogas, we have to collect the biogas, store, condition for safe and beneficial use. Then we can use it for electricity and heat production, okay, by converting the biogas into power and thermal energy. Or we can use it as renewable natural gas, or we can also use it as bio CNG, which is purified and compressed fuel. We can safely burn to prevent the methane emissions. Now, on the feed side, we have the major challenges on the waste collection. So we can have on-site organic waste collection unit, okay, where we can collect the manure and other organic matters, okay, for delivery to the digestion facility, or we can have off-site waste recycling and processing facility that receives the external waste and conditions it for compatibility with the digester plant. Okay. Now, when you will condition it for digestibility of the waste plant, you will also have reject material and containment. Therefore, we have to make a way for that as well. So herein, if I talk about this, as I said, the manure can be treated and managed through several processes, either individually or in combination. Now, the first step for this is, of course, the organic collection. Okay. So as I said, there are two possibilities, on site, off site. Okay. Now in this, what happens? The manure is gathered and placed at centralized location for processing. Additionally, co-digestion feedstocks such as food waste, scraps can be delivered to the facility or prepared for digestion. Okay. Now the method of manure collection influences the physical and chemical properties and generally determines the most suitable type anaerobic digestion system for a farm. For example, we have flushing system that uses water to clean paints or lanes that produces manure with low total solid. We can scrape or vacuum the manure shortly after excretion process, feedstock with the higher total solid and volatile solid. Volatile solid represents the organic portion of the total solid, and if manure is not collected properly, it may begin to degrade aerobically, reducing the volatile solid content and overall energy potential. Okay. Therefore, the manure collection is very important, particularly if we are using a flushing system which has lower total solid that helps us to make a suitable plant. Then we have digester. Now, after the collection and preparation, the feedstock is fed to the anaerobic digester, which is also called as anaerobic reactor. Okay. Now, these digesters are designed in such a way that they create optimal condition for microorganism to carry out their symbiotic biochemical reactions and thereby converting the organic waste into the biogas. Okay. The digesters also capture and recover the biogas for energy use. There are different types of digester we will discuss in this course as well. That includes the ambient temperature covered anaerobic lagoon digesters, medium or high temperature tanks made of steel and concrete. There can be fixed film, there can be something. Then we have biogas storage and processing. So, that when biogas is produced, temporary storage is necessary. So, we call it surge vessel. So, let's say this is my, if I have to develop a PFD for biogas plant, so let's say this is my digester. Let's say this is my digester. So, I will put a pump here that will take the slurry, and this is a slurry pump. Now this will give the feed here. This is digester. It will have a agitator. Then from here, either we have to take the gas out, so we can have a vacuum pump or a blower or something kind of that. Then as I was saying, the biogas handling and storage. So here, because we want a continuous supply, we can have a surge vessel. Or maybe we can put a surge vessel here. Surge vessel that actually counter the fluctuation. So in the gas production, sometimes when less gas is produced, this compressor which is working here will get the continuous supply even the gas production is lesser, because there will be some gas in the surge vessel, and then from here we can send it to purification unit, and from purification we get the methane. If we have to fire it directly, we don't need to even remove the CO2 from it. Okay. So as I said, that the biogas produced necessarily, requires a temporary storage. The one idea is that, of course, to avoid the fluctuation or to balance the production with demand. Okay. Now this storage is built into the digester itself. Okay. So we have this digester, and then there is a freeboard space. Okay. The freeboard space between the digested material and reactor cover, which is usually flexible membrane. For medium to long term storage, flexible bladders and tanks can also be used. Okay. Now this methane content, as I said earlier, that in the biogas typically range from 50 to 75% with the remainder mostly CO2. CO2 also range from 30 to 50%, and the trace amount of H2S commonly around 2000 to 8000 ppm, okay, but can go up to 15,000 ppm. Then we have water vapor and other minor compounds such as ammonia, etc. Okay. Now here what we do, once it is collected, so once there is a storage vessel, we collect it, then we have to process it. Now as I said here, if you look at this as, so the biogas has CH4, CO2, H2S, H2O, NH3, etc. Okay, so first step we do for biogas processing is to remove the moisture. Okay. Now, what happens when the warm biogas cools in the pipe? The water vapor condenses and captured in the water trap. Then we have to remove the H2S, for which we use a adsorbent. Okay. And if we don't remove the H2S, because it is very corrosive, it can corrode the system. Also, it is a toxic gas, so it has to be removed. Then additional cleaning and conditioning, for example, for electricity generation, this depends on the type of energy recovery unit. If you have to use it for the vehicle, then we have to remove the CO2. Okay. Therefore, the removal of CO2 is required, like I was showing. Okay. Then there is co-product separation and treatment and storage, which is the digestate. So as I said, here we get the biogas, the other co-product is digestate. Okay. So digestate, what we do, it is used for multiple purpose. For example, so this can be used as animal bedding, this can be used for soil amendment, okay, or bio-based products like bioplastic, etc. It also requires solid liquid separation because in the digester, as I said, it is in the slurry form. The biomass is like total dissolved in the dissolved solid form, so it is very less, so more water will be there. So for digested, whatever is left over there will also have more water. Okay, so what we do, we recover the solids by mechanically pressing it, or we can use screens or screw presses. Okay, once the water is removed, we can use it for land application. Okay. Now, depending on the digester and feedstock, digester may be liquid, slurry, or stackable material resembling the compost. Okay. Usually, you say in the regions, if you are making the digestate, you can use it anytime in your garden or in your farm. But let's say there are demographic regions where nutrients cannot be applied throughout the year, and digestate has high nutrient. So, what will you do? Okay, you will have to store this digestate for a long time. Okay, therefore we need a storage system. Then we have processing. The solid digestate from dry fermentation system is used for soil amendment. Okay, so it can be pelletized, formed into blocks, or shaped into the bulk. Okay, these are very important for the soil which lacks the nutrients and organic matter. Okay. Now, coming back to the liquid stream. So here, like I said earlier also, I showed you that in the digestate, once when we press it against let's say we use a screw presser. So what will happen? The solid and liquid will get separated. Okay. So the remaining liquid contains nitrogen, phosphorus and potassium. Usually 3 to 4.5% dry matter, 2 to 6%. Okay. Therefore, it can also be used directly as a fertilizer. Okay. Or it can be further refined using post-processing technologies to produce nutrient-rich concentrated fertilizer products. Okay. Now, let's discuss about the factors that affects the anaerobic digester process design parameter. So, of course, one parameter is the feedstock moisture content. The first, I would say that what kind of feed you have. But let's say we have a good feed, so the total solid actually are very important. So if you ask what is total solid, these are percentage of solid in the liquid. Okay, and these terms are mostly used for selection of the appropriate type of digester. For example, if we have total solid less than 3 to 5%, okay, then this kind of feedstock is suited for covered lagoons, okay, or you can also use fixed film, or you can use induced blanket reactors as well. But covered lagoons are more suited for low solid containing the slurry. If my range of solid is between 5 to 13%, then this kind is suitable for plug flow digester, okay, or mixed digester. If 12 to 15%, then we have plug flow digester. So if it is greater than 20%, we have high solid feedstock. It can be high solid feedstock digester we can use. So I can say that if I have less than 3 to 5% covered lagoon, other you can also use, for example, you can use induced blanket, you can use upward flow. If you have 5 to 13% total solid, I am talking about, okay, the biomass content, mixed digester. If 12 to 15% plug flow digester. If you have greater than 20%, then high solid anaerobic digester. Okay, so the moisture content, or you can say the total solid content in the feedstock, is one of the most important parameters that helps us to decide the type of digester or reactor we will choose, and that eventually affects all the process design parameters. Okay, now typically if we look at, if we have total solid between 0 to 5%, we can use covered lagoon or attached media. If we have 5 to 15% or 5 to 13%, we have complete mix. Okay, now usually when we have 0 to 5% total solid, my feedstock is classified as liquid. When I have moisture content between, I mean the total solid content between 5 to 15%, so 5 to 10% is defined as slurry, where we use the complete mix. Then up to 15% is like a kind of semi-solid, where we use plug flow. And if it is more than 20%, okay, then it is defined as solid feedstock. Then we have high solid anaerobic digester, HSAD, etc. Okay, that means you can see the moisture content in the feedstock is very important parameter for designing the kind of digester. Then what kind of manure collection and recovery system we should have, that also impacts the overall design parameters for the anaerobic digester or the biogas plant. So herein, it's the method and timing of manure collection directly affects the biogas yield. Okay. For example, if the total solid content is 3 to 5%, it is usually suited for covered lagoons. Okay. Now, in dairy farms particularly, the manure can be collected using water flushing system, scrapers and vacuum trap. Okay. Now, this flush system moves the manure with water into pits or holding tanks. So, it dilutes the manure, increases the volume, increases the both biogas production and digester sizing. Because when more moisture is there, more water is there, the digestion will become easier. But because of the more water, the digester size will increase. Okay. Now, the amount of manure recovered also depends on the collection method. Okay, or otherwise you can do one thing, you can leave the manure as it is for sun drying or in open pits or lagoons. But the problem is that it will be susceptible to aerobic process, and that will cause the loss of volatile solids and therefore a reduction in the biogas production. Now, the other important parameter for design is the operating condition. So, what are the operating conditions under which we want to work? Okay. So, for example, we have cyclophilic or ambient where we work below 20 degrees Celsius. Now, these digesters mostly rely on natural or solar heating. Okay. And effective digestion can occur down to about 10 degrees Celsius, but activity is very slow. Then we have to increase the temperature. So when the operating temperature is 30 to 40 degrees Celsius, we call it mesophilic or medium digestion. Now this is most widely used range, especially 30 to 37 degrees Celsius is very optimum. Okay, it strikes a balance between the efficiency, cost. Okay, but although faster than the cyclophilic, but it is also a slow process. Therefore, it requires longer retention time. Then we have thermophilic. We can increase the further temperature to 50 to 65 degrees Celsius. Okay, particularly 50 to 60 is the optimum condition. Okay. Now, when we increase the temperature in thermochemical process, also we learned what happens when we increase the temperature. Eventually, it helps to increase the rate of reaction. So, the digestion will become faster at this temperature. But because heating is an additional source of energy, so it requires cost. Okay, and the process stability becomes a greater challenge. Also, beyond this, many of these microbes may not survive. Okay, so that has to be taken care of. The other important parameters are hydraulic retention time, which is very, very important. So the HRT refers to the average time waste stream remain inside the digester for stabilization. Okay. Now, this is typically optimized to maximize the biogas production. If we extend the HRT or the hydraulic retention time, so there will be more exposure of the biomass or total solid to the microbes, and therefore there will be better digestion, and that will lead to higher gas yield and better quality digested. But then if you want to increase, you will have to build bigger digester if you want a continuous process. Therefore, it will increase the digester size and the overall project cost. The other factor is the digester volume, like it is directly correlated with the hydraulic retention time. So, digester volume required depends on the daily quantity of waste being treated and selected HRT. Besides that, how many number of stages should be there also affects the design parameter. Okay. In most of the cases, a single stage process is used where hydrolysis, acidogenesis, methanogenesis, acetogenesis as well happens all together in one reactor. Okay. But in some cases now we have seen that there are two stage systems that separate the first two steps from the methanogenesis. Okay. And because of that there is a improved stability, but because now there are two reactor systems, so that will require higher capital cost, and because there are two reactor system, the operating cost will also go higher, so it requires higher capital and operational expenses. The biogas yield, of course, is dependent on the HRT, but for the design parameters it is very important. It directly influences the project's energy output as well as the revenue generation potential. Now, it's not like that, so we can say that the parameters that affects one is the operating condition, or if I summarize, the parameters that affects the biogas design plan are first feed moisture content, then we have the manure collection system, we have type of digester, we have operating parameters, then we have other parameters, and there can be so, I mean the other, when we say we have HRT, we have volume of the digester, we have number of stages, we have biogas, I mean so many factors are there, okay, that eventually affects the design of the biogas unit, okay. So I think this is all for today's class. We'll discuss about the different types of digester, because I said like the type of digester. One more thing we missed is the composition of feedstock is also very important. Although we can't control it, composition of feedstock. Okay. Now herein, when I said the type of digester. So of course, I told you, I mean, when do we use covered lagoon? When do we use fixed film? When do we use HSAD? When do we use induced bed reactors? But we will discuss in detail in further class also that what kind of digester is suitable for what kind of feedstock, what are the major products, what are the major advantages and challenges with those products. But that we will discuss in the next class. This is all for today. See you in the next class. Thank you.